Hello everyone. In this video, we are going to look at an example of data integration. As we saw in the lecture, there are a couple of known challenges when it comes to data integration. The first one, and the one that we are going to address in this video, is an example of entity identification problem. One of the examples that we saw in the lectures were when we had the data sets of the yield of agriculture with the treatment of the agriculture. And we saw that that could be an entity identification problem. And now we can actually see an example with the data and how that is an entity identification problem and how we can resolve that. So let's get to it. All right, so first thing we will do, we import the modules we're going to be using. And of course, like I said, this is going to be the example we're going to be working with. We have two data sets. We have yield.csv, which basically shows the location, the GPS location of the center of each piece and also the amount of crops harvested. And also the GPS location of 128 irrigation systems stationed throughout the field and the amount of water that they get. So we have these two data. Let's go ahead and take a look at them. This is the treatment data. We have longitude and latitude, and then also we have water, and then we have the yield data. We have longitude and latitude and the amount of harvest received. So let's go ahead and take a look at these visually and sort of like look at this data, get to know the data using a visual tool. So what better visual than scatter plot, and it's sort of like using color to show us what's happening in the field. So the treatment data, we have these treatment points that we have the longitude and latitude as shown here. This is longitude and latitude, and also the amount of water that was dispensed by the water station located in that point. And we are also using color map, CMap color map, to sort of like show how much water was sort of like dispensed. So if the blue is lighter, there is less color, less water. And if the blue is like darker, it means that more water was dispensed from this location. And also we can do the same thing for the yield DF, and now we will see that there are much more data points for the yield DF, and also the water with the points that has higher harvest now also show darker points. So sort of to put this into perspective, the data sort of comes from a field something like this. So you have a combine that is collecting the harvest, also is collecting some data at some point. At whatever point that these harvests are collected, it also collects how much harvest was collected, and then also how much water was dispensed by these water stations. So now the question is, if there is a relationship between the amount of water we are giving and the amount of yield that the ground or like the agriculture is giving. So there are two approaches here. We could go ahead with a visual approach, and to do a visual approach is very simple. We just need to put these two visuals together and see if there is sort of like that visual relationship between them. So once we do this, we basically have to just put these two on top of each other and make sure that the scalings are sort of consistent. So once we do that, we do see some relationship. You can see like the blues and grays are more light here, and once you move towards here, the blues and grays they're darker here. So I mean, like, we sort of see this relationship, but there is nothing like doing actually showing these numbers connected. But the problem is for each of these water data point or treatment data point, there are more than one yield data point. We don't really know the relationship between them. I mean, one of these yield data point could belong to other water data points. So that relationship is very difficult to sort of like be assumed here, and there is none. So for us to deal with this situation, we have to come up with some assumptions. So let's go ahead and sort of like get rid of the color maps on this slide, like in this visual, and like have all of them assume as the same. So we can assume that when a point or a yield point, data point, is sort of in the radius of a water station, the amount of water that was dispensed from this water station has had influence on that data point. So we are making this assumption so we can actually make that one-on-one connection in our data. So it's basically an assumption I'm just making, and a lot of times when you go about data integration, especially for cases like this, these assumptions are necessary for your project to be able to progress. So we make that assumption, and so I go ahead and calculate the radius of, for example, one of these points. So like for example, I'm calculating the radius of this one. So I'm assuming the radius of this water station is half the distance between these two water stations. So water station 1 and 0, and I'm calculating their latitude, like the difference of the latitude, and I'm assuming that the radius of this water station is sort of like the distance between these two. So that's what I'm assuming. So I run this, and this is the radius. So now I have to be able to calculate a distance between 2 points, because this function is going to be important in the next function I'm going to be using. So we know the calculate formula for distance is the square root of the difference between the first dimension power to 2 plus the difference between the second dimension power to 2. So this is like a formula we know. For us to be able to calculate the square root, we have imported the math module. So this is a function we just created. Now we want to sort of like put that assumption into practice and sort of combine or integrate these data. So the way we are going to go about this, we are going to create a function that we are going to apply to the treatment data. And basically on each of the rows of the data, we are going to see if that row or if that point, treatment point, was in the radius of each of these water stations. So for all of those rows, we go through a loop for all of the water station, and if that water station's distance from the data point was less than the radius, then we assume that had some effect on the yield of that yield data point. And then sort of like add the water amount based on a sort of like a coefficient. And this coefficient is calculated based on the distance between the yield data and the water station. And the closer the yield data to the water station, the higher the coefficient. And this is another assumption we are making to integrate this data. So once we run this, we now have this function. Now we apply this function to all of the rows of the yield data. Once we do that, now we can put the result of this function into the amount of water this yield data object received throughout the throughout this process. And we can see now there is a one-on-one relationship between the harvest and water. So we were able to integrate the harvest data with the water data. And we can see that we had a challenge for the entity identification. We didn't know what entity to sort of connect with each other. So we created this some assumption about having some water entity that didn't really exist based on some other data we could rely on. So now we can simply do a scatter plot of the water and harvest, and we see that there is somewhat of a relationship between the two. Of course, the relationship sort of like gets even higher after the amount of water has increased for these process. And we can also do the correlation between harvest and water. And what the number we are looking at is like really we are interested to look at is this number, which is 0.23 correlation, which is not of very high correlation, but still is a positive correlation. So we can see here that the amount of water had positive impact on the amount of harvest.